building the Wolverine amplifier, input stage test, and main board build. In this video, where we left off, a quick test of the input stage, bias potentiometer orientation, filling the vias note, starting the main board build, and a second group by. There's a poll. So I want to emphasize, please don't forget, if you're mounting your boards parallel to the heatsink, make sure that your potentiometers are accessible from the top of the case. So on one channel, the potentiometers will be in the opposite orientation you need to make sure these are set as per the build guide. So here is the input stage test wiring as per the build guide section for testing the IPS standalone. I chose to do a quick test to make sure it was functioning correctly prior to moving on to the main board. That input terminal is getting replaced. It's not high enough quality for this amplifier. Here's a better view of the wiring. Please note the 50 mA fast fuses I used to ensure I did not do any damage in case of a fault. If you're planning to do this test, please use a current limited power supply or 50 mA fast fuses to protect the Wolverine you are creating. Okay, so I'm labouring the point about these fuses. It's pretty important if you're going to do this little check. Here's an overview of the power supply setup I used, which is 2 dual tracking laboratory power supplies. The digital multimeter is measuring the DC offset at the output terminal of the input stage. You can measure the DC offset across the output at the negative feedback terminal and adjust R25 to achieve as close to 0 millivolts as practical. This multimeter is measuring the constant current source CCS1, which is set to a voltage drop of 5 volts across test point 1 and test point 2. To set this, you adjust R11 for 5 volts. I set my power supplies to a maximum of 50 mA output and slowly increase the voltage. When running the input stage board by itself, it draws approximately 20 mA. Here's a small signal test I ran to make sure the input stage was functioning correctly. This step is optional and it may be more appropriate for fault finding if you have an issue. The reason I chose to do this test in small sections as I build the amplifier is to ensure each step is working correctly. I want to mention it's not necessary to load the input stage for this check, nor should you load it at this point because you risk doing some damage. So with 100 millivolt RMS input, you should see around 2.8 volts RMS output. So definitely there's some amplification going on there. So note that the output signal is an inverted mirror image at this node in the circuit. Here are some square waves. So I looked at the rise time just for a bit of fun. As you can see with the oscilloscope probe as a load and without the rest of the circuit, there is some overshoot and ringing, but it's well controlled. I expect with the rest of the circuit completed, this will clean up a lot. So let's make a start on the main board. I ended up remaking the wire links in solid copper for a little more clearance from the output trace. You can see they're raised up. See the gap underneath now? I started installing all of the small components such as diodes and the small resistors. If you bend the leads with a bending tool, you can have a nice result with no mechanical stress on the part. I often tack solder the part in at the top of the PCB before soldering in fully from the underside of the PCB. To do this, you can use 25 to 30 mm spacers to hold the board up off your bench. I then moved on to the large rail reversal protection diodes, and the next largest resistors I have J103 also installed at this stage. Don't forget to install one pot up and one pot down to ensure access from the top of the case for biasing, just like the input stage board. Please preset the bias pot as per the build guide, as this step is critical. So I don't know if you noticed my mistake here. I accidentally installed all 4 diodes at D105A, D106A, and D105B and D106B. Make sure to mount resistors with a power rating over 1/2 a watt, 1 to 2 millimeters up off the board. I used an aluminium spacer, which was 2 millimeters high, to provide consistent height as I soldered in the larger resistors. So things are starting to come together. Please refer to the build guide for the value required for RCC. It's dependent on the beta value of Q103 and Q104. I installed the links in the D105B and D106B locations as per the build guide at this step. So you can see with the red arrows in the picture. So initially I made a mistake and I had diodes there, but this is the EF3-4 board and I'm planning to use 57 volt rails. I measured and matched a few MJE 340 for my VBE multiplier transistors Q103 and Q104. Since I chose Q103 and Q104 transistors with a HFE value of 144, my RCC value is then 75 ohms. It is worth using some pieces of wire or component legs that you might have trimmed off to fill the vias for the high current traces on the PCB. Something to consider if you're not sure if the solder has fully wetted and flowed through and filled these vias successfully. Also, if you'll use the little piece of aluminium trick that I did, don't forget to take it out. So, don't the Vishay Dale resistors look nice? Don't ask the price of these though. I have a couple of resistors to swap out if I want to have all Vishay Dale, and you can see the flux which will be cleaned off soon. In the next video, I plan to continue the Wolverine build, continuing onto the main board more so. I've also just found out that there's a poll for a second group buy for the Wolverine PCBs. I'll leave a link in the description for the poll. Please register your interest if you missed out on the first round, or if you simply want more PCBs, perhaps to build some kind of multi-channel monstrosity. So thanks for watching, please like and subscribe, and don't forget the subscriber competition. Leave a comment if you want to be in the draw, and leave your DIYaudio.com username in the comment section. The boards to win are pictured below. Bye for now.